Okay, I'm just about finished with valuation and the weighted average cost of capital and the tax effects of interest and this kind of difficult issue, which is not so really difficult. And if you go to the website, I have these things on computing the cost of capital, and then I have some I hope there's no background noise here. And then I have some video explanations and files for our cost of capital adjustments. Okay. Now, the last two videos I'm going to make are about this target capital structure. And here's some of the points. Here is the biggest reason, the biggest point of all. I remember, now this has been years ago, and it's taken me this many years to answer a question. I was teaching a valuation class. Yes, I do that. Not only project finance, I was teaching a valuation class, and somebody asked me in Canada, I remember in Montreal, what about this whole target capital structure? Shouldn't we use the target capital structure instead of the actual capital structure? I think I answered no, but I really hadn't worked through it. Now, when you work through what I'm going to do is work through an example where we have a current capital structure that's not equal to the target capital structure. And we'll show that after you segregate the cash flows, whether you use the target capital structure or the current capital structure, if you do the discounting correctly, it makes no difference, no difference, no difference, and that's without any taxes. Now, when to do this, I'm going to demonstrate how to use this interpolate function, because we're going to gradually switch from an actual to a current capital structure to a target capital structure. And the key is if the cost of equity is consistent with the capital structure, the whole thing doesn't make any difference. And you can use the WACC or the net of tax method. If there are no taxes, it doesn't make any difference. Everything is fine. So the reason is, if you start getting confused by this, don't. And the only theoretical thing to really consider is that the the beta on the equity that you measure and then relever and unlever and all that, that beta on the equity better be consistent with the historic actual capital structure. Okay, and when you unlever and relever, it's supposed to go away. So here are some of the assumptions. I made a debt to capital current of 60% and then a future one of 40%. And then I said it takes 5 years to get there. So I made a little table over here. And excuse me for just 1 minute. I'm going to move these up, because if you have a table like this and use the whole line, you want to make sure that that line isn't kind of polluted by anything. So we're going to go from a 60% down to a 40%. And then we're going to change the credit spread, which we really should do. As the debt goes down, the cost of the debt should go down. That's our whole leverage beta. And then I'm going to say that key thing here is the cost of equity, the all equity beta. All of those other videos that I made about unleveraging and releveraging the beta, they're supposed to come out with the cost of equity for an all equity capital structure. And then we have a growth rate. That's the beginning level of assets and a growth rate. And then we're going to get some valuations. Now the key thing here is these valuation, when we do this with the WACC or the cost of equity, if there's no tax, this is all very simple. You take our standard DCF model, We take out the current value of the debt from the 60% current value, and then we get the equity. And then we get exactly the same equity value when we do a whole discounting of the equity cash flows, and if we do it correctly. And here, so let's start. So the first thing I did was I just grew the assets, and I should have probably done something a little bit nice here. You know, if you do this sort of thing, where you put the assumptions over here, if you'd ever just have to copy the, oops, and I forgot to press the F4 on purpose, okay, and then we say, well, here's our, I'm going to say our return on capital equals our cost of capital. You know, let's make it a little different. Let's put our return on capital, and let's make that a number. Let's make that 8%. So we're earning a little bit more than the cost of capital, and watch me screw everything up by this. Okay, so it didn't affect anything, so we're earning more than our cost of capital, and we're growing. Okay, now here is the big thing. If I went to the, you know, here, I'll just show you what I do. There are now in this Excel 2016, there are, I put the generic macros, look up and interpolate. I don't know if you can do this in the old ones. And you right click, you don't want to do this, but I pin them so I can always find them. Those are the three files, three of the things that I would really take from the website. And I continually update these kind of things. So if you, you know, of course, I put them, and I've got to stop the video now because somebody is interrupting me. Oh no. I was just interrupted for a minute, so excuse me, I'm not in the right place. Oh no, that was stupid. If you just go to the home page, and then you have those same kind of three files. I also included a reporter and the waterfall charts, but those are the key files. Now, once you have that, and you have this, did I open it? Let's open the one called Look Up and Interpolate. And then I've shown this 1,000 times before, probably don't get sick of me. You go to Functions, you press Edit, you press Control-A, Control-C, close this, you go back to your file, alternate F8, and I've already got it, you'd press Edit, and you just paste it. Not so hard. And once you have that, notice how the debt to capital goes down, and that's because we used interpolate lookup. We looked up on the year, and then we clicked, just like we use a regular lookup function, we clicked on this entire line, the entire line, and then clicked on this entire line. So if we would wait till 10 years, and we would have then we would see the thing gradually going from 60 to 40 over 10 years, and this one just doesn't, this one uses a compounding, it uses a kind of compound growth rate, so we have a bigger effect. It goes down faster and then gradually goes slower. This is just a straight line interpolation. Equity is just 1 minus the debt then, and then I do we say, and this is the key thing, that the overall cost of capital is 6%. Now that's totally the key, okay? Because if the overall cost of capital is 6%, then we subtract we take account of the debt cost, and this is the one that another interpolate lookup function, and then we multiply the debt cost by the debt to capital. I used the linear one, and then the equity capital is just the total cost minus the weighted, the amount that's in the weighted average cost of capital. Okay? Control P, and then the equity cost is the weighted, what's in the weighted average cost of capital. This is the equity cost multiplied by the capital structure, so you divide it out. I've done that too many times, and it gradually goes down from 9 to 7.67. That's the equity cost. Notice the overall cost of capital stays the same, and I just put a little check here that says you take the debt cost times the debt, equity times equity cost, and we get the same weighted average cost of capital. And I could call this, in addition to WACC, and KE check. Okay? And then we have the interest cost, which is just the total economic value of the assets times, in this case I used the weighted average. I could have taken the value of the assets multiplied by the debt percent times the cost of debt, and then we say how much income goes to equity. Now that's not exactly the same as the equity cash flow, because we have to change the value of the debt. The debt is the total value of the company multiplied by the debt to capital percent. Now that changes, and when the debt goes down, that's a negative cash flow. We got to pay it off. If the debt goes up, it's a positive cash flow. So the total equity cash flow is the difference. The debt cash flow is the sum of the interest and the change in the debt. Now here's the interesting part. When I take the first thing, okay, this gives us our standard WACC. So this is just our economic value of the assets minus the value of the debt, which is just the debt percent times the value of the assets. So we get an equity value of 1,223, which is the equity value up here. Okay? And I'm going to put a 0% growth rate here. And just a minute. Oh shit. I'm going to pause for just a minute. Okay, tiny bit embarrassing because I changed the cost of capital, and I should have discounted the economic value of the assets at our all equity cost of capital. So I'm going to just use this rate, okay? And then I'm going to fix it over here, all right? And when you do that, you get the total value of the company, okay, and the total value of the equity cash flow. Now, the equity cash flow is down here. It's the amount of income to the equity minus the debt cash flow, and so that's the equity we get. Now, that's the debt. This is the equity. Now, if you would notice the cost of equity changes, so you can't use a normal discounting, but what you can do is create a little index. And you just, this is the equity cost of capital, and you just allow the index to change. And after you've allowed the index to change, then you take the net present value by taking the sum product of the equity cash flows, and you divide it by this little index thing. Not this little, the index of the equity cash flow that's changing. And notice, with the changing cost of capital, you get exactly the same number. And then you can also do the same thing with the debt. The debt cost is changing here, so you can compute an index value on the cost of debt. And this debt cash flow is then the debt cash flow divided by the index thing, whatever you want to call it. Okay? Now, let's just make sure it still works. If it doesn't, I'm going to have to pause it again. So we put a different growth rate, and we still get the same answer, right here and right here. And I don't care how much you change it. It doesn't matter if you put a different target capital structure in, you get the same answer. And that's all because, and you put 80% capital structure as the target. Who cares? What you care about is how much debt is taken away from the current value of the company. Okay? It doesn't matter what the target capital structure is. Do not get confused about the target capital structure. The only relevance of the target capital structure
is that perhaps when you're computing the asset beta, but even after that, you want to use in your cost of equity calculation, you want to use whatever the current cost of equity is associated with the existing debt, and you don't want to distort the cost of equity. That's the thing. I don't know if I explained it or not, but don't get confused and don't think you have to do something about the target capital structure. Goodbye. One more file on this, and then I'm back to project finance and credit analysis, which is probably a lot more interesting to most of you.